know, like Maya's going to be way off task. I'm going to pick on Maya because she's always on task and like fine. If Maya's way off task today, I can easily copy paste the YouTube link, send it to her parents, and say, hey, check out Maya in class. Just FYI. So don't make me do. Normally this class doesn't get recorded, right? But today you are. So let's be on task. I need 7th grade behavior, right? On 4 on the back, the bottom right box should have been 0.08. And of course, if you don't understand the generic rectangle multiplication, you're like, okay, why? Because on your paper, it said 0.8. The reason it's not 0.8 is because there are 2 decimal places being used to make that multiplication. Now still, you might be like, but how did we get there? So I'm going to start from the beginning. They wanted to multiply 6.2 and 3.4. We know that we could do old school standard algorithm. There was a box back there, but apparently they're gone.
Oh, I see it. Box.
Could you open those and stick those on the back table, please? That was very ironic since I just brought up like you being on task. We break up our 6 and our 0.2 and our 3 and our 0.4. Hey Ray, what's going on, man? I keep trying to teach and I'm trying to help you guys answer a question that's on the follow-up, and you've been moving around and talking and like, what can I do to help you be ready for class? Or do we just need to make some better choices? Probably that. Yeah. So be with me on number 4 on the back of the follow-up. Anybody else need anything from me before I can keep going? Because this is taking us way too long to get rolling. Juan, you good? Yeah. So as soon as I ask that, you turn to Max, and I assume you're telling Max what you need. 3 times 6 is easy. 18, we could do that part all day long. But then we come out to these pieces, and if you don't know how the generic rectangle works, we've done this already. I just didn't ask you to master it. The 4 and the 6 multiply, make 24, but we have 1 decimal place, 1 decimal place.
That means we would go 1 decimal this time.
Absolutely. The 3 and the 2 do the same thing, make 6, but there's 1 decimal place. Where they goofed up and I didn't catch it, because guys, quite frankly, I copied this from the answer key. That was a CPM issue. So I have an email to send and let CPM know, hey, your key's wrong. This comes from 4 and 2 makes 8, but how many decimal places do we have? 2. So that should have been 0.08, but now the rest of the question. So even if you realize that was wrong, the rest of the question says, now, how do we find the final answer? Anyone want to help me out? Naomi, how do we find the final answer? We add them all up. So if you're not done with this question yet, take a moment right now, write down what you want, and then you want to show that we add up all the pieces to find the final answer. Any questions remaining on that one? Any questions remaining on the follow-up at all? All right. Now it seems like we're ready to roll. So yesterday's lesson, distributive property, still those notes. So you should be continuing those notes. Take a minute or 2, turn in whatever you need to turn in. Get those notes out if you don't have them out. And we will dive in and try to go as quickly as we can. Yes?
Wait, you wanted to follow up in these turned it separately.
Yeah,
right?
follow-up is its own thing, and then the homeworks can be stapled.
I'm not gonna say that I'm bad at the portion work, but like I need to practice with it.
Okay.
And it's like this one was confusing. They both were.
Mr. Safety, Mr.
So
Safety.
always fraction equal to a fraction. Right, 4 cupcakes in 15 minutes, and it asks us about an hour. How many minutes are in the hour? How do we go from 15 to 60? If we don't know the multiplication, we have to divide backwards. So you have to type in the 60 first. right, we had skipped this problem, so quickly draw a sketch of these two shapes. Actually, hold on. Give me everyone's eyes up here. So I got a lot of people doing a lot of things. You're still turning stuff in, whatever. We are going to sketch these and then write expressions for each of their perimeters. We're not doing area today, we're just doing perimeter. So sketch them on your paper. And then I would go around the shape and label each different part. And remember on I, this part is going to be the weird section. And over here on double I, this part is going to be the weird section. Take a couple minutes, sketch those, try to write out what the perimeter is. I gotta put these rules back in the scheme.
How do we know what the dimensions of the little boxes sticking off?
They're usually one.
There you go, guys.
How do we know that?
Because they know it. Because we've done it. We have algebra tiles. Have you ever seen these algebra tiles that Remington uses now? So these are what we're doing all of our study of algebra around, and we start by just saying, okay, what is one? What does it mean for an object to be one? So it's 1 unit by 1 unit, whatever our units are. So they know that anytime we have a small square in an image, it's a 1 tile. Anytime we have an x squared, it is an uncountable dimension. So CPM did a really good job of this isn't 3.7 or what it is. And actually a student of mine made this for me to say x, all of these x dimensions aren't a fixed dimension. They're actually like stretchable x or flexible x. So then from there, what we saw earlier this week is, well, that lines up there, this lines up there, meaning that rectangle is 1 dimension by an unknown dimension. We'll call it x. Then they step it up and start to use y's. So x by y by 1, y by y. Yeah, so it's all, they just start to know. So the little ones don't have to be labeled up there, they just know. Hey, we're going to rapid fire this, which means I'm just going to go 1 question per person, boom, boom, boom. To the please don't, sorry. That's what I'm doing. Max! Max V, what is this dimension?
The dimension of that side?
Yes. Just x. Logan, what is this edge? No Logan today? No Logan today. Well, yeah, okay, no Logan in here, right? Actually, I think he just ran by. What is this dimension, Layla? Layla, what is this edge? 2, because we have a 1 here and a 1 here. This is 2. Then Kyla. What do you mean? Kyla, what is this? Ooh, if we put it all together, it could be 3. It's a 1 and a 1, right? So depending on how we look at it, I'm just going to say 1 and 1 then, since it depends how we put it together. Luke, what is this around here? 3, right? 1 and 1 and 1. Morgan. What is that length? Hey, I don't know why we have side conversations, because I bet about 80% of us, actually I bet about 95% of us could not tell me what length that is. Actually, I can't even tell you what length that is.
It is x minus 2.
If we put that with it, it's x minus 2. Everyone put your hands down, put your pencils down for a second.
But because we don't know where the
This
block is.
length right here. No. Do not fall in that trap. It looks like it's 1. We don't know that though. That is a part of x, but so is this, and so is that, and so is that. So I don't know what this is either. Might be 1, might be 20. We don't know. But we do know the whole side is x. So like we talked about yesterday, take away this section for the 1, take away that section for the 1. Both of those together are x minus 2. Who's confused about y? Maxton, why are you confused?
don't. It does not make sense to me, and what would happen to would happen if for the x then if because the perimeter would be then x plus 9. So would that be
Well, hold on. So let's back up to the x plus 2. Let's make sure that all makes sense. So my purple line that I just drew it straight down. It's x, right? Because the edge of the x tile is
right?
x.
No, that would not be 9.
All right, yesterday's my tile.
That would be 7.
So, what do you mean that'd be 7? We don't know what x is.
No, the one from the perimeter that steps in x minus 2.
Okay, I need you with me, Max. Give me your eyes. This purple line. Forget about all other problems. That purple line's x. Are you with me for that?
Yes.
Because it's the edge of the x tile. Now, when the one tile butts up against it, it starts to take things away. So if I take away that, how much did I take away?
1.
1. And if I take away this, how much did I take away?
1.
Another 1. So that's how what's left over, what I have as red, is x minus 2. But those pieces together, right? If I look at one of those individual pieces, I don't know what it is. We do not know what one of those individual pieces is. Because we don't know how far up or how far down this block has been slid. Because we just don't know. Layla?
Why wouldn't it just be x minus? Why would? I think it's a question. Okay, why would it not be like just x minus 1? Because that block right there. Why wouldn't it just be? Yeah, why wouldn't it just be x minus 1? Because
Step over here with me. So, first thing to talk about was the x squared tile, because we had these issues this morning. What is the length or width of an x squared tile? What is this green line on top?
X squared.
Not x squared. It's x, because remember, x squared is the name of the tile because it's a square with edges x. That's why it's x squared. Naomi?
If you look back on your notes yesterday, that's the same thing.
Mm-hmm.
Like with a different one.
Yep. So Layla, stay with me here. This red line right now is x, right? So then I pull this tile in, and it takes away that amount of the x, right? So right now my red line is x minus 1. You with me for there? So then I pull this tile in, butt it up against my shape, and I lose this amount of my x. So now that red section over here is x minus 2. Does that make sense on this shape?
Yeah, because it makes sense because there's 2 blocks. It's on the sides, not in between.
So visualize this red part and that red part. If I slid that block up, it's the exact same as what we see over here. The length that's remaining.
Oh, I get it.
So visualize, if I move that up and move the red down, it's the same as right here.
Is it also x minus 2 because there's 2 spaces to take them out?
Yep.
Okay, that makes it much more easy. Thank you.
Isn't it all? It's still x minus 2 because they're both the same length.
So let's imagine this. If I brought in another 1 tile and dropped it right here, what is this length left over?
Minus 1.
Ooh, it's
No,
x
minus 1.
minus 3. This would also be taken away then, right? That would also be taken away. But right now it's x minus 2 because it's x, take away 1, take away another. Questions? Okay.
Why does algebra keep telling us to find a vector? It clearly isn't coming back.
Well, it's lonely. Every now and then you think about your ex. You reminisce back to the good old days. No, they're normally not good old days. This length across the top, the only thing we didn't get was 1. Hey, the side chatter needs to stop. Because that either means you're confused and you're compensating by talking about something else, or you're just being immature. Because we have stuff to get through. So is anyone confused? Do you have a question to ask? So if we walk around the shape and gather up like terms, I got an x here. I got an x here. Any other x's?
No.
Nope. So how many x's do we have? 2x. Then get our constants. So 1, she threw something away. Again, I'm not talking to everybody here. Stop reacting like small things are big things. 1, 3, 4, 5, 6, 7, 8. What do I end up with? 6, right? Because I had 8 minus 2. 2x plus 6. Over here, well, crap, we have a lot more to label. Back to rapid fire. Is Kieran here today? Yeah, Kieran. How long is this whole edge? Or we can break it up. We're going to break it up. How long is this part? X. How long is down here? Ooh, careful. Yeah, there's 2 down here, so it's really like x plus 2. Across the bottom here, Ray, what's this length across the bottom? X. Absolutely. Dana, what's this edge right here? A 2. Maya, be careful because I'm asking this in a weird way. What's this section? 3. And go ahead, this section is also 3. Any questions? And you could break it up differently, or you could mark each of the ones as just ones. Any questions? Now gather your like terms. How many x's?
4.
Ooh, I'm going to switch back to the right color. X, 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 X. Remember, this minus 2 doesn't matter. We're just looking for x's. Then we'll get the minus 2. So perimeter equals 4x. Now let's get our constants. 2, 4, 7, 10,
That would be
8. So 4x plus 8. Any questions how we found those? No, not really, like no questions, or no, not really, like I'm confused?
We're good.
So then, we're going to practice like we did yesterday. What if we know what x is? Right? There was an S word that we said if someone comes and tells us what, substitute, right? So what if now somebody shows up and they're like, hey, you've been trying too hard. X is actually 5. Figure out what our perimeters are. If somebody shows up and tells you x is actually 5, figure out what your perimeters are.
You like it what you see.
Ready to figure this out? Start a song. I have a meeting here. I don't even know if it's gonna get easy. You did? Both of them. Yeah. Both use X. X is 5 now. So anybody struggling?
I am.
no.
For my blue perimeter. Let's go. Morgan, what do I do here?
Okay, so basically it would be 2, and then in my head I kind of did like parentheses, I put 5, so 2 times 5 is 10, and if you put parentheses first plus 6 is 16. So you're
So the perimeter there is 16.
units.
Ooh, U for units. Very good. Maya, what about the second one?
Well, you have to do 4 times 5, which is 20,
Yeah, which this is 20, and then,
plus 8, 28.
and again, it's perimeter, so it's just units. Questions?
Nice guy, so many problems. But keep it on there.
What?
Keep it on there. That's what I can't see.
She's just
It's right here.
It's the end of the world as we know it. It's Yep. I just like to start singing random songs when they're freaking out.
Sing Hugger.
No, you were acting like it was the end of the world, so I started singing. It's the end of the world as we know it. All right, are we good now, Lexi? Do I have your explicit permission to move on?
Yeah. I just wanted to let you know that I tried to let her do my business, but she didn't want to.
We got 2 more things to get through. On your own, because this shape is less complicated. Sketch this on your own, which means there should be no chatter. Label each of the different sections with its length. And like over here, you could do all a bunch of 1s, or you could put them together. Same thing over here. You could do a bunch of 1s or put them together. Then solve each of these situations for the various x values. So I'm going to give you like 90 seconds probably to get a head start. Then we'll double check our perimeter expression together. And then we'll substitute together. But right now, you're on your own. You're sketching. You're labeling. Then we're solving. Sketching, labeling, solving. It might be similar to something on your yellow sheet, but I don't know. We're doing this here now. I'm asking you to sketch it. So x squared means it's a square that is x by x. So remember, Keegan, up here for the x squared, the length that makes it an x squared is x. And the height or the width or whatever we want to call it, each of those dimensions is x. Does that make sense, dude? So when you come over to like the right side or the left side, it's a modified x. Right, so that left side, just above that one tile, along that
Stop being mean.
the whole thing would be x, right? The whole vertical. But if we take away that one tile, ooh, x minus 1. Not the same thing, because remember, subtraction can't be flipped around. We're going to do this together again. If you're good on it, you can just keep working. That whole length would be x.
Minus 1.
However, when we take that away, what is red?
Minus 1.
X minus 1. This whole length would be x. However,
There are 2 blocks.
That's so easy. In my opinion.
yeah, please try not to say numbers out loud while we're all calculating. That makes it hard for people. Now, Kayla, I'm going to throw you a toughie. And not like a toughie tire or anything like that. Like, if we do the entire bottom, somebody says, how long is the base?
X plus 3.
Hey, notice how I said Kayla?
Oh,
Yeah, because we have 1, 2, an x, and another 1. This whole bottom would be x plus 3. But then, this section is how much? Anybody? 3. You may have broken it up differently. I'm color coding. I think I can fit in one more random card. Vera, how about this section? Where'd you go? Oh, sorry, you're hiding in the back today. The orange. Break it up if you want. Yeah. Yeah, you got it. So it's either 1 plus x or x plus 1. I like what you said, though. That's 1, and then that's x. So you got 1 and x up there. What am I forgetting?
Units. The one to add them up.
Down here. Careful, I didn't get down there. That's 2. Gather up. How many x's? 4, right? So our perimeter is 4x. Grab your constants. 1. I'm going to do positives first. 4, 7, 9. We might as well go back to 8. And then ooh, we end with 6. Not 4x plus 8 today, actually. It's 4x plus 6.
What?
away from that 4x plus 8. And this was where I made that silly joke this morning about 4x's because you date around and whatever. But you are substituting for each of these. You're going to replace the x with whatever they tell you. And you're going to do it 3 times. Give you a minute head start. I doubt you solved all these already. If you have, just hang out.
I solved all of them.
Question? I don't want answers. Right?
Oh, okay.
You saw all these things? All 4. So if I call on you to give me the answer, you got it?
I didn't do all of them, but I have them.
Because we're still going through the stuff. 30 seconds.
Oh no, I'm just done.
Ray, is that question or answer? What's your question, dude?
So, I'm still confused on, like, I know, like, we have to multiply, but I'm still confused on how, like, do we do, like, 4, like, because, like, the 4 and the x are connected.
Yeah, how are they connected? There is multiplication in here. So that, when we go to substitute, that's that critical word that eventually we need to learn, we just replace the x with that number. But I love that you just asked that, because if you just write 4 or 5, that would look like 45. So instead, when we substitute, I forget who said I visualize it with parentheses. Yeah, that's what we should be visualizing.
That was Caleb.
So it's 4 times 5, then plus 6. So what's 4 times 5?
20.
20 plus 6, 26. Any questions on A?
No.
Kaylin, in B, what do I do?
You multiply 3 times 4. It's obvious what that is.
Okay, what is it?
12.
Senorita Obvious.
Oh, thank you.
Maxton, what do I do in C?
Okay, you times 4 and 2. And then you add 6.
What's 4 times 2?
Add 8.
Add 6.
Plus 6, 14.
So I'm assuming that those of you that are having your own side conversations are ready for the mastery next week. And I'm just letting that happen. And Keegan, what happens when I do 4 times 1? You get 42. So serious answer, what happens when I do 4 times 1? We get 4, and when we add 6, we get 10. Any questions here? I got one more thing to do, and we're done. Caleb? They are all units. Thank you very much. They are all just units. I was just trying to do the math moving fast. Didn't label. My bad. We should label. Maxton?
You right.
But technically, if it's adding, would it be 20? It would be 200.
Yeah, it's written a little sloppily. It's just 20 plus 6, 26. We did this yesterday, right? That should be on your notes when we practice distributing and factoring. That's the one last thing that we want to review. So if you had 20, write this down on your paper, please.
Wait, what?
21x plus 7. And Phoebe, if you were asked to use the distributive property, now here most students would say, well, there's nothing to distribute, but we talked about this yesterday.
There is.
Right? Not that we're going to distribute, but we actually go backwards in a way. What here do we pull out of these values? What can both values be divided by? 3. I know why you're saying 3. Your brain's ahead of you. 21 and 7, what can they both divide by? 1? 1 doesn't change anything. They can't divide by, this can't divide by 3. Dana? 7. They can, but nothing changes. Hey, I'm worried because a lot of you are acting goofy when you don't know how to do this. Now I know we're not expected to master it till next week, but come on, if I gave you a test on this right now, we've done it. Like, you should at least be mildly comfortable. When we divide that 7, it becomes the number out front. What goes in the parentheses? Phoebe? That's why your brain was thinking 3 is 3x. What's 7 divided by 7?
1.
1. Because if we wanted to get back to the start, we would distribute and distribute. Any questions here? Made it back to max V.
Yay.
Alright. The rest of the time, yeah, I did all that. That was just random freaking cards.